Okay, we have Tevin and Stacy that leave from the same restaurant and the same time traveling in opposite directions. If Tevin travels 13 miles per hour and Stacy travels 9 miles per hour, how long until they are 110 miles apart? So because we're dealing with distance, rate, time, we're going to want to use this formula, distance equals rate times time. And whenever I'm doing these kind of problems, I like to do a table. Ooh, this is not going to be neat. Let's see if we can make it a little neater. There we go. Okay. So let's first start with the distance. We know they're going to be 110 miles apart, so they've started here and one maybe has gone a little further, right? So we know this total distance is 110 miles. But it's tricky, we can't say 55 each because, you know, they're traveling at different speeds. So Tevin's going to be a little further than Stacy is. But what we can do is we can say, well, let's call Stacy's distance x. Okay, let's go ahead and label these. We'll call Stacy's distance x, and so then we can call Tevin's distance whatever is left over. And so that'll just be 110 minus that x. Okay, so for Stacy for the distance, we'll put x. For Tevin, it's just whatever is left over. So 110 minus whatever Stacy traveled, or x. Now we know Stacy traveled 9 miles per hour and Tevin traveled 13 miles per hour. Now another thing, they didn't tell us the time, but they did leave at the same time, and we're just wondering when are they 110 miles apart, so the time is actually going to be the same for them. Okay, so we'll just put t for time for both of them because we don't know what it is, but we do know it's going to be the same. Now, since we're trying to solve for time and we have just t in this location, to me it's going to be the easiest if we rearrange this distance equals rate times time to be solved for t. So what I'm going to do is go ahead and divide each side by r, and this is something it actually often happens when you're doing distance equals rate times time. Sometimes you want to rearrange things so that they can be written a little simpler. So we'll do this, so then we end up with d over r equals t. Okay, so we're going to do that when we write out Stacy's. We're going to say, okay, Stacy, d over r, so x over 9 is going to equal t. And when we write out Tevin's, again, d over r, so 110 minus x is our distance over 13, which is our rate, is going to equal t. So now we've got these two equations. These two make up our system of equations. Well, since these are both equal to t, we can use our substitution method and put this one in place of t up here. Because if they both equal t, that means they both equal each other. So we'll have x over 9 equals 110 minus x over 13. And then we need to solve for x. So we have a fraction equal to a fraction. So when we have this, you could find the LCD and do it that way, but I would recommend just cross multiply this. So we do x times 13, or 13x, equals 9. Now we need to times it by this whole 110 minus x. So make sure this goes in parentheses so that 9 gets multiplied by this entire 110 minus x. Okay, we'll go ahead and distribute. So we get 13x equals 990 minus 9x. We want to solve for x, so we add 9x to each side. So we'll get, so I'm running out of space here, I'm going to take it over here. So we get 22x equals 990. We need to divide by 22 on each side. And we get 45. So this means, oops, so if x equals 45, that tells us that Stacy traveled 45 miles, right? And then Tevin traveled whatever 110 minus 45 is. But the thing is, we're not looking for the distance, we're looking for the time. How long until they are that far apart? Well, we also figured out that t equals x over 9, right? this one right here. And so we're going to take that t equals x over 9 to figure out our time. So t equals 45 over 9, so time is just going to be 5 hours. Now you could, to double check yourself, you can put in, you could solve both of these for x and make sure solve both of these for t. So, you know, do x over 9 here, and then do 110 minus x over 13 here, and make sure you're getting 5 for both. And then you can also put in all of the numbers and make sure they're coming out equal on both sides. But anyway, this is one way to do this problem. So again, set up your distance equals rate times time. You can set up your, when you don't know a distance, you just know the total, you can use this x and then 110 minus whatever that distance is and go from there. Let me know if you're still feeling confused.